corporate finance practice problem using Excel. Cumulative voting. How many directors can we elect? Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information's on the left-hand side. We're going to populate that into the blue area on the right-hand side, looking at cumulative voting again, but this time, question a little bit different. Two questions we can generally look at, and there's two formulas for them, although, of course, they are related in nature, which we will show when we'll do the math up above. So we have the shares required. That's what we've looked at in the past when the question is basically, if I want to elect this many people, say to the board of directors, which is what we are applying it to here, but note that you could think about this for other kind of areas such as government type of elections or some other nonprofit elections that are using a similar cumulative voting process. Then you can also say, well, what are the number of directors that I can elect given the voting power I have? So in this case, given the number of shares that we have, what are the directors that we can elect given that voting power? So that's the question we're going to be looking at this time. The second one, what number of directors can we elect given the number of shares that we have? So remember, the nature of the cumulative voting, slightly different than the straight voting. In this case, we're imagining the boards are going to elect 20 people. So normally you might have a vote, for the 20 people that are going to be taking place, but that would favor the majority because if you had, of course, 51% and you were, electing or voting on each one individually, then whoever has, the majority interest would win. But if you use the cumulative voting, then you might be able to consolidate some of the minority vote. That's going to be the general idea of it. So the idea then being, or the function then, is going to say the outstanding stocks that we have times the number of people that are going to be elected, in this case 20, will give us the number of votes that will be out there. We do not have to vote all of our votes on each seat, however, and we can consolidate our votes. That's going to be the difference that allows us to, isolate our votes or put our votes towards one particular area. So if this is what we have the minority shares are going to be the 10,500, the board seat to elect 20 people, and there's 55,000 shares then outstanding. So then our question is, well, if we have the 10,500 shares, how many of these 20 seats can we elect if we do a strategic electing type of strategy? This would be the second formula down below, the number of directors that can be elected, but I'm going to plug it into the worksheet that we used for the first formula just to see how they're related mathematically clearly. And so when you're doing this in a book problem, if you're doing this for a test situation, you kind of want to know what the relationship is, because if you have to memorize the formula, it might be easier to memorize the formula that way and then plug in for an unknown instead of trying to remember multiple formulas and just trying to just remember them rogue with repetition. Just see that they're related, plug in for the unknown, and so on. Here we're going to plug this into our worksheet. Obviously, if you had a worksheet set up and you calculated for this first formula as we did in the past, then you can use GoalSeek to kind of back into that. And in practice, that's going to be a very useful tool in many different areas. So we'll start off with that. So let's imagine we're doing this first formula where we got these shares required, the number of directors times the total number of shares outstanding. Now, the number of directors, that's what we don't know. So that's going to be the unknown up top. I'm going to choose a number just so we have a starting point. That number then will change and we'll make the adjustment till we get to the endpoint to be what it needs to be. We'll use a GoalSeek tool to do that. So I'm going to start off with just, let's say, 6. And I'm going to make that yellow because that's the one that we're going to be changing. And then we're going to say the shares outstanding are going to be equal to the 55,000. And that's going to give us then the numerator. Going to underline here, home tab, font group, underline, multiplying this out. This is going to be 6 times the 55. That'll give us our numerator up top here. And then we're going to divide by the total number of directors to be elected plus 1 for the denominator. So the total number of directors to be elected is going to be 20. And then I'm just going to add 1 to that, plus 1, 20 plus 1. And that's going to give us our denominator. And that's going to be equal to the sum of these two, 21, in other words. We can then divide those out because we have the numerator and the denominator. I'm going to underline here, font group and underline. Dividing this out, this is going to be the 330,000 divided by the 21 gives us the 15,714. Now we're going to take that whole thing and just add 1 to it. So we're just going to add on 1. We'll just tack on 1 to the end of that and underline that font group and underline that. That's going to give us the shares that would be needed, which is the shares that we already have. So this would be the one that we have a known to, which we have the 10,500 shares. So I'm going to then add this up. This is going to be this plus this. So this ending number should be 10,500. We're at the 15,715. Then we can adjust our number up top until we get this bottom line number to where it should be 10,005, for example, making that 5 and so on. And of course, we can use GoalSeek to do that for us. So let's do that. We're going to go then up top to the data information, what if analysis, analyzing with the what ifness. And then we're going to say we want to set this cell to be, I'm going to hard code this in there, the 10,500, which we know it should be 10,005, by changing this cell up top, that 5 up top. So once again, we want this cell down here to be 10,005 by changing the cell up top. We're going to say OK, and there it does it. So we're at 4. Let's add a couple decimals. Home tab, couple decimals. It's 4.01. And notice that you're generally going to drop the fraction over here. So we'll typically leave it at 4 would be that what we would generally be at, because you can't really elect 0.01% of somebody, of the 20 people. We have elected, 0.01% of the board. That's not generally, because that would be a fraction of a person. You know what I mean? Okay, so then let's go ahead and think this through with our second. Let's think of our second calculation down here. So we did it basically backing into it with this formula, solving kind of for the unknown, but with GoalSeek. Let's look at this second formula. We should get to the same thing. This is the number of directors that can be elected. So that's going to be the shares owned minus 1 times the total number of directors to be elected plus 1 divided by the total number of shares outstanding. Let's go ahead and make that into an Excel worksheet. I'm going to do that down here in the second calculation. Now, if you look at a book problem or something like that, they'll probably, just like always whenever they're changing up the formulas, they're not going to explain to you how these formulas are related. They're just going to say, hey, here's the formula. That's how we did it. But again, if you're memorizing formulas, it's useful to know how they're related, because that'll give you a better idea of what's going on. It'll make it easier for you to memorize a formula if they're forcing you to do so for a test type of question. So we're going to take the shares owned minus 1. So the shares we own minus 1 is going to be, we own the 10,005 minus 1 is going to be the 10,499. And then we've got the directors to be elected, which is going to be, and that's plus 1. So we got the 20 here plus 1. So that's going to give us the 21. So that's the number of directors needed plus, I'm sorry, not that one. The shares owned times the total number of directors to be elected plus 1. So shares owned plus 1 times the total number of directors to be elected plus 1. That's our numerator. We're going to multiply that out to get the numerator. So we'll multiply that out, underlining here, font group underline, multiplying this out. This is going to be the 10,499 times the 21. There we have it. Then we're looking at the denominator. The denominator, which is simply the total number of shares outstanding. Total number of shares that are outstanding. These are outstanding shares, meaning they're outstanding. Okay, and then I'm going to underline that, font group and underline. Then we'll take the number of directors that we can elect then is going to then be equal to the 224,479 divided by the 55,000. Let's add the decimals, number group, adding a couple decimals there, we're at the 4.01 again. So we get to the same kind of situation, obviously related formulas here. So then let's take that information and think it through. So we're saying, okay, so does that make sense? Because if we have the 10,500 shares, does it make sense that we can vote, we can pick up 4 out of 20 board seats? Let's kind of mull it through. We'll do our little mulling through scenario. So let's say we had the outstanding shares how many shares are outstanding? There's a total of 55,000 shares outstanding. And there's the people that are going to be elected, there's 20 of them. So we get to multiply that times 20 to get the total number of votes that are out there that can possibly happen. 55,000 times 20, 1,100,000 votes that are out there. Font group underline. We're going to assume we're the minority interest, and then everybody else we're going to put in the majority. So it's just we're going to assume it's us, and then everybody else, and assume that it's a worst case scenario where they know what we're going to do and they're going to try to stop us, but they shouldn't be able to. Is the idea. We're going to hope that's going to be the thought process in our game theory type of analysis. So we're going to then say, okay, we're going to then have our votes add up to the 10,005. That's how many shares that we have. And then we get a vote per board seat. So that's 20 of them. So font group underline. That means how many votes do we have that we can consolidate. 10,005 times 20. That gives us the 210,000. So that leaves the majority other people that we're imagining they're going to try to stop us here in the worst case scenario. And so we're going to take the 55,000 shares minus the 10,005, 44,500 that they could use to stop us times 20 board seats. We're going to say font group underline. That gives us the votes at the 44,005 times the 20, or the 890,000 votes that they can try to use to stop us. So let's just kind of work this out and say, okay, well, what if we then have our candidates over here? We pick up our candidates and we're just going to name them the alphabet of candidates. Alphabet of candidates. It won't let me paste like I want to here. So paste it, and then home group and underline. I'm just put the alphabet A through V here. And then I'm just going to label 1, 2, and we need 20 of them. So I'm going to go all the way down to 20. These are more than we've seen in the past. Let's pick it up to 20. So that's how many people could be elected. You got to be in the top 20. So it doesn't matter where you lie, but as long as you clear yourself to be in the top 20. So then our strategy is to pick up 4 of them with the number of shares that we have. So we're gonna consolidate our votes here. We've got 210,000 votes divided by 4. And then we're going to pick them up. We're imagining that A, B, C, and D are our people. That's who we want there. Let's total it up on this side. That means they're going to have a total vote. If nobody else votes for them, which is our assumption, nobody else is going to vote for them because they're trying to stop us. So we're going to say, there we have it. And if we have our total down here, we're going to equal the sum of the total. So there we have it. There's our 210 that we allocated out. Now, everybody else, we're going to imagine that they're going to try to consolidate their votes to try to kick out one of these 4. Can they do it? And that's the question. So let's imagine that they were not going to vote for any of our people here, and they can't vote no. They're going to not vote for any of our people, but they're going to try to beat our person. Now, they could try to tie, and that would be a funny situation, and we should still be okay. I believe the math works out that if they try to tie, we should still be okay, but you would think they'd say, okay, I'll try to beat 52.5, and they've got to beat enough people to kick out those 4, meaning they gotta clear the rest of them down here, which would be the 16. They'd have to have 17 people to kick out this last one. I believe that's right? So let's say we had 52,501. Let's check it out. And then say that's how many we're going to allocate all the way down so that we beat out these guys up top. And we take that all the way down to 20. And I got to get this last person. That last person needs to be in there so that I can get one more in there so that we beat out one of these top 4. That's what the other people are saying. So that's how they could beat us out. So we can say, all right, well, how many votes do we have left? We've only got 890,000 total minus the sum of these that we just handed out, that we thought about. So that's the 49,984. So see, it's not enough to beat these 4 out. Now, again, you could think of a scenario where they say, well, what if they tried to pick up one more vote for all of these by trying to tie? And so now you have a tie situation, and it still wouldn't work. This last one still isn't enough, even if they tried to tie it out. And then you'd have that weird situation where, there'd be a 20-way tie there, and then you'd have to debate on which one was higher. I think the math works out that even if you were to try that, this one, you still couldn't get that last one in place, and but I'm not completely sure on that. If they did try that strategy, it would be kind of funny, because then you'd have to determine what the tiebreaker rules would be and whatnot. So, anyways, keep that in mind. But in any case, this last one isn't there in this case to beat out the first four. If we were to copy these over just so we can sort these, and let's imagine that these first four are ours, so I'm going to make those green. These are the people that we're locking down to be on the board. All right, and then so if I copy these and put them into our table so we can sort them, I'm going to paste them 1, 2, 3, just the values, and then I'm going to copy the totals over here, copy the totals, and I'm going to paste them for just the values. And then we want the first four, A through D, that's our people, font group underline. If I was to sort this and see who won, say, okay, let's sort it from Z to A, then these people are still on top here, of course, because we had a tie for all of these and they couldn't kick us out. Again, if they tried to beat us, normally you would think this, in this situation, it would be kind of funny because all of these, they're still within the top 20 and they all have exactly the same votes. So that doesn't matter. There's not a problem there. But if this last one happened to be higher and then you had a 20-way tie for everybody else, you'd have to determine which one of that 20-way tie wasn't included, and then that would be a funny kind of situation. You would think, though, these guys would try to beat them by having one more vote, and if that was the scenario, let's copy that over. Let's do that again. Let's delete this, and so I don't mess it up. I'm going to delete this and copy this over. I'm going to copy that and paste it. And then I'll copy these and paste it here. So paste it there. And then sort it once again. I'll sort it over here, Z to A. So now you can see that they can beat us out from all of these people can beat us, right? Our four people. So the person that we tried to get in there, A, B, C, and D, are at the bottom of the winning slot, 17, 18, 19, and 20. But it doesn't matter. That's the point. They're above the threshold, and there's no particular status for someone who got the most votes. In theory, that's how we're imagining the situation to be, and therefore, as long as you got into the top 20, then you're good. You're going on to the finals, right? You're cleared the hurdle. That's all you need to do. So that's the idea. This last one would have to push out. They'd have to get one more in there to push out one of these four. So that's kind of the strategy. Now, remember that it doesn't mean that obviously the other votes are going to work out this way, and nobody, you might be in a situation where you don't know what the other person's going to do. There might be a substantial amount of people that you don't think are going to vote at all. So you might have a very more complex kind of scenario of what you think is going to actually happen. But the question here is well, how many people could we basically guarantee, to be on there, even if we had a worst case kind of scenario? That's the idea.